Okay, we're going to talk a little bit more about inheritance and really just kind of more general stuff about Java inheritance. I mentioned before that when we inherit, we get all the public data and public methods for free. I want to go into a little bit more of the rules about how we access things when we have an inheritance relationship. So we said that public members in a base class remain public in the derived class. That's true of both data and methods. If you can access it from the outside in the base class, you can access it from the outside world in the derived class as well. However, private members in a base class are inaccessible in the derived class. So if you mark a piece of data, for instance, as being private, the derived class will not be able to access it. It really is hidden. However, the derived class still absorbs that piece of data. The derived class still has the piece of data. It just cannot be directly accessed by the programmer who's writing the derived class. Now, hopefully, if there is a public method that accesses that data, that public method is still available, so you can still refer to that piece of data going through the getters and setters. This makes the implementers, the people writing the derived classes, kind of like the outsiders who we might want to shield them from having to know about the inner workings of a class. That was the whole point of encapsulation in the first place. So that's not necessarily a bad thing. That allows me to derive from a class and not really have to know about the data that belongs to that class. Now there's another type of access level that's called protected. And protected members are accessible in the base class by the people writing the code for the base class, and protected members are accessible in the derived class by the programmers writing the derived class, but are essentially private to anyone outside of those two people, anyone outside of that class hierarchy. So you would use protected when there's data or methods that you define in the base class that you would like only the derived class implementers to have access to. Sometimes you'll do this when you know there's a high probability that the creators of the derived class are going to need direct access to a data member. Okay, there's three types of access: public, private, and protected. If you don't mark something as either public, private, or protected, it has this fourth access level called package access. And what it means to be package access is that the member is hidden to the outside world, except for the other classes in the same package. They can access the data member directly. Okay, it's kind of like it's public data. Okay, so let's review. A package is a container of classes that are all related to each other. Packages are used primarily to avoid naming collisions. So perhaps you want to create a class for a sewing program called string. To avoid confusion with the built-in string class, you can create a sewing package and place your string class inside of it. The fact that it's in this package makes it distinct from the built-in string class. Now the built-in string class, by the way, it does live in a package. It lives in the java.lang package, and this package has the fundamental classes in the Java language, and is so important that you don't even have to import it. You always have access to classes in java.lang. So if I'm building a series of related classes for an accounting ledger system, I might create a package called receivables and place all the classes related to receivables in that package. Since those classes are related to each other, it might make sense to let the classes peek inside of each other and have access to each other's data. Now some might argue that this and actually the protected access level violates the information hiding principle of encapsulation, and I would probably consider myself one of those people that thinks it's probably not a good idea to use package access or protected access. I think we should be trying to hide data from as many people as possible, so that makes it pretty easy for that data to change later on. Okay, next let's talk about this thing called multiple inheritance. Okay, so in Java, unlike in C++, we can only have single inheritance. So let's pretend we had this set of classes. let's say we had this class called A, and I don't know, let's say we had a piece of data called age. Right? And we had another class called B. B inherits from A. And we have another class, C. C inherits from A. Right now, this is perfectly fine. We can do this in both Java and C++. However, if we did something like this, if we had another class called D, and we said D inherits from both B and C, we call this multiple inheritance. Okay, and what I'm saying is, in Java, we do not allow multiple inheritance. Okay, one problem with multiple inheritance is this diamond relationship. So if A has a piece of data called age, does that mean that D has one copy of age or two copies of the piece of data age? And this is a little bit tricky. So the Java team basically decided multiple inheritance is more trouble than it's worth. And although you might think this would be useful in some cases to have this ability to inherit from two different parents, it does get a little bit tricky. Now later on we're going to talk about a way to basically simulate this type of relationship without all of the pitfalls that go with it. And we're going to talk about interfaces coming up shortly, and we'll be able to simulate multiple inheritance with interfaces. Now in C++ you can do this. You can have a class inherit from more than one parent. And there's even a way with a keyword or two to make sure that you only get one copy of the data age in this case. But we'll kind of stop talking about that here. Okay, every derived class object has a reference to the part of the class that it inherits. Right? So when we have some object, let's just look at A and B. Right? There's some part of this object B that comes from the class A. Right? So there's B. When we create an instance of object B, B might have some additional data, right? But it absorbs some stuff from the class A. Now, when you're inside a method of the B class, you always have access to this thing called super. Super is a reference to the part of the object that comes from the base class. Okay, you can reach this part of the class using the keyword super to refer to the base class. So let's go back to remember our bar class extends foo, and remember the foo class had this method called print, and we decided to override print. Right? So we said instead of saying system.out.println inside foo, we overrode it to say system.out.println inside bar. Now, if you want to call the base class print function, you can do that using the keyword super. Okay, so if you have a reference to a bar object and you call print, it's going to print out both inside bar but also inside foo, because we're saying we want to go to the foo part of the object and call the print method that came for free in the foo class. Okay. Another place we would use this super reference is in a constructor. So every class must provide its own constructors, and derived class constructors should call the base class constructors as the first thing it does. Okay, and we do this again with the keyword super. Okay, so let's pretend we're implementing the foo and bar classes again. So we start out with this foo class. The only difference here is that we have this private data member called number, which is an integer. Now, of course, if we want to create a bar class, we'd say public class bar extends foo. Okay, and let's say we want to add some data to the bar class. Let's have maybe a private string called address. Okay. So we need to provide a constructor for the bar class. And since a bar extends a foo, the bar class has room for a number and an address. So chances are in the constructor for this class we're going to pass in both a number and a string for the address. Okay, so what we're going to do, the base class foo already has a constructor that takes an integer. So what we want to do is we want to call the base class constructor, and we do that with this syntax here. Okay, this must be the first thing that happens inside the derived class constructor. It has to be the very first line of the bar constructor. Then we can do other things like call the setter for the address piece of data. Okay, so again, there's another use of the super reference. This is again a pointer to the part of the object that comes from the base class. Now, it turns out we do a similar thing in C++. So if we were writing in C++ in this bar class, right? Remember this scope resolution operator. Okay, so this is how we specify the bar constructor. Right? But before we get to the actual code, what we would do is we would put this colon in between the function header and the function body, and we'd give the name of the class, and we'd pass in the piece of data. So this will basically call the foo constructor for this bar object, and then we would set the again the address equal to ADDR. Okay, so just so you know, we do the same thing in C++. Of course, the syntax is awful, or it doesn't make a whole lot of sense. But in between the function header and the function body, we give this colon and the name of the class, the base class constructor that we want to call. Okay, default constructors, those with no parameters, are called automatically, and you don't have to do anything with super if you have a default constructor. Okay, since we're talking about special references, now is probably a good time to talk about the this keyword. So this is a reference or a pointer to an object. This always refers to the object which has the flow of control. So remember, in an object-oriented system, the flow of control moves through many different objects. And this always refers to the object that contains that flow of control. Okay, so this is used in Java in a few different ways. Okay, so the keyword this is used by an object to send a reference to itself. Let me say that again. This is used by an object to send a reference to itself to some other object. Okay, so let's pretend we had a relationship here between a car class and an owner class. Okay, so every owner owns a car, but a car also belongs to an owner. There's a two-way relationship here where both the owner knows about the car and the car knows about the owner. So we could have this public class car. Okay, it's going to have a reference to the owner. Okay, there's probably going to be a constructor for the car class which expects an owner. And then inside here we're going to do something like this. Owner is equal to O. Okay, I'll do some other stuff here. And then we have the owner class. And it's also going to have a reference to a car. And it's going to have a constructor. Oops. And just for fun, let's say the actual car object is created inside the owner constructor. Okay, so what we would do is we'd say car is equal to a new car object. But of course, a car object, when you create one, requires a reference to an owner. And we haven't quite constructed the owner object yet. We're actually in the middle of constructing it right now. Well, one object can pass a reference to itself to another object using the this keyword. Okay, so now we're creating this car object and we're saying the flow of control is going to jump to this class and it's expecting an owner object. This refers to that object, that owner that is going to own the car. Okay, so that's one way we use this. It's used by an object to send a reference to itself to some other object. We can also use this to distinguish parameters from class data members. Okay, so let's look at the car class again. We said we were going to have a private data member of type owner called owner. Okay, last time we just passed in the value O. Right, that was the name of the parameter. Now we're going to use the exact same name as the parameter, the exact same name as the private data member as a parameter. Okay, so you might be confused now. We have this parameter, which is like a local variable, and we have this this owner, this instance data, this data member that belongs to the class. We can't just say owner is equal to owner, because the compiler wouldn't know which one are we talking about. Are we talking about this one or this one? Well, there's a way to identify these or separate these two. If you say this dot, okay, this dot owner always refers to the data member that belongs to the car class, whereas owner without any this dot, that always refers to the local parameter. Okay, so that's another use of this. You can distinguish parameters from class data members. There's another reason why we use the this keyword is to call one constructor from another. Okay, so maybe we have a constructor that does kind of all the work, and we want to reuse this constructor. Okay, so again, we'll look at the car class here. So we have this default constructor, this constructor that takes no parameters. But let's say we also had another constructor that actually took an owner object. Okay, so we have these two constructors. One takes an owner object. This one takes nothing. And here, what we decided to do was to create a new owner object. But the question is, well, how do we call the constructor that does all of the work? Well, that's, again, another use of this. You can call one constructor from another. And here we'll create the new owner object and just pass the flow of control to this constructor that's already expecting an owner. Okay, so we talked about super, we talked about this. Let's talk about static now. Static doesn't really have much to do with inheritance, but since we're getting a lot of things out of the way here, now would be a good time to talk about static. You can have a static data member or a static method. Now, a static data member is a variable that is shared between all the objects of a class. Okay, so if we were working on this this car class, let me create yet another instance of the car class. Okay, we can declare a piece of data as being static. I'm going to say private static int number of cars. And I'm going to assign this piece of data the value 0. Okay. And now what I would do in the constructor for the car class is every time a new car object is created, I might want to increase this count, number of cars. So I have number of cars plus plus. Okay, we can also have static methods. Okay, so this private static int called number of cars, this is shared between all objects. And here we're initializing this integer right in the declaration. So in Java we can do this with actually any piece of data. Right when we declare it, we can give it an initial value. The thing is, with static pieces of data, we must initialize it here. This is our one and only chance to initialize this integer called number of cars. Now, whenever anyone creates a car object, obviously the car constructor is going to be called. And for every single object created, we are going to increase this shared instance of number of cars. So number of cars belongs to the car class. This is a kind of a classic way to count the number of objects of a certain type that you have. Is you make a piece of data static, and then that piece of data belongs to the class, not the objects. So again, I've said this before in class, the class is the cookie cutter, the objects are the cookies. Well, this piece of data belongs to the cookie cutter, and there's only one copy of this piece of data, no matter how many objects, how many cookies you stamp out with the cookie cutter. Okay, now a method that's marked as static is one that can be called where you don't need an object to the left of the dot. So in this case, we could say car dot get number of cars, and that would tell you exactly how many instances of car objects there are. So we've seen this already with our JOption pane, show input dialog. Right? Notice never do we actually create a JOption pane object with the new operator. Now you cannot access non-static data from static methods. So get number of cars, that's a static method. If I had another piece of data that belongs to a non-static piece of data that belongs to the car, so for example, I think we were talking about owners. Right. This is a piece of data that belongs to the car class. Every single car object has its own owner reference. Well, we cannot refer to non-static data in here. This would give us a syntax error because, again, we don't necessarily know that there is going to be a car object in the system. And if there's no car object, then there's no owner. And if there's no owner, then we can't get the name. Okay, so you can't access non-static data from static methods. Since there might not be an object to the left of the dot, there might not be any data to use in the method call. You can, however, access static data from a static method because the static data belongs to the class, not the object. And you know for sure the static data will exist. And then one last final bit of information. There's a keyword final in Java. If a data member is declared as final, it's constant. You get one and only one chance to set that value when you declare the piece of data. So the syntax is very similar up here. Very often you'll create a public final static int, and then you'll initialize it right there all in one statement. If a piece of data is declared final, you get one and only one chance to set that value, and that makes it a constant. That's what it's there for. If a method is declared as final, it cannot be overridden. So we talked about overriding the behavior in a derived class. If you want to prevent that from ever happening, you could mark that method as being final. And lastly, if a class is declared final, it cannot be extended. So you might want to, for example, the string class cannot be extended. It is marked as final because we don't want people to be able to mess with the functionality of a plain old string.